Very good morning, students. Hope you are doing good. Be safe from coronavirus. Stay at home and do your preparation. In that perspective, I am sharing the first part of Unit 5, Design of IC Engine. In this first part, I will be covering the design of cylinder and cylinder head. The procedure for design of cylinder and cylinder head is divided into 7 topics. Namely, first we will be designing the cylinder stroke and bore. Then we'll calculate the thickness of cylinder wall T, thickness of cylinder flange Tf, thickness of cylinder head Th, diameter of bolts or stud Db, diameter of the pitch circle of bolt and flange, and finally we'll calculate the pitch of the bolt. So here is the first step to calculate the cylinder stroke L and bore diameter D. In the figure you can see a dry liner type cylinder, inside having an inside diameter, bore diameter capital D, and you can see that the water jacket is separated by a liner. We need to calculate the thickness of liner later on. As a first step, we have to assume L by D ratio, and L by D ratio is taken as 1 for air cooled craft engine and is taken as 1.2 to 1.35 for all other engines. So generally we will assuming L by D ratio as 1.35 for solving the problems. To find the cylinder stroke L, we start with the mechanical efficiency of an engine, which is given by brake power by indicated power. So indicated power of an engine is calculated by PM LAN upon 60 into 1000, and PM indicate the indicated mean effective pressure in Newton per meter square. L is the piston stroke in meter. A is the cross-sectional area of the cylinder in meter square, which is given by pi d square by 4. D is the cylinder bore, and N is the number of power stroke or cycle per minute, cycles per minute. So usually N is equal to number of revolutions, RPM of the engine in case of two-stroke engine, and N is equal to N by 2, that is the speed in RPM upon 2 for a 4-stroke engine. So this is a very crucial step. So you have to see that whether the cylinder, whether the engine is 2-stroke engine or 4-stroke engine, depending on the type, there is a stroke of the engine, you need to select the N value. So here PM, L, A, N all will be the given data, and you need to calculate the indicated power, or you may be asked to calculate the brake power. So here you can see that the brake power is calculated including the efficiency, mechanical efficiency, and it is also possible to calculate the brake mean effective pressure PBM, that is nothing but the multiplication of the efficiency and the mean effective pressure. Sometimes the maximum gas pressure may be given, and we can calculate the PBM from the relation P max approximately equal to 10 times the brake mean effective pressure. So after finding the so from the previous formula, brake power formula, usually in a problem brake power will be given data, and you need to calculate the value of length of the stroke and diameter, bore diameter. So from the formula of brake power you can see that I can represent L by D ratio. So I can convert either L, you can have it as a L or you can have it as D, and area is also given in pi d square by 4. So it is better to have L in terms of D, area also in terms of D, brake power is given, PBM is there, or efficiency and PM are there. You can calculate what is the diameter, and from diameter having the L by D ratio you can calculate the L value also. So after calculating, we will finally calculate the length of the cylinder, which is given by stroke addition of stroke, top clearance, and piston length. So usually the compression ratio is represented as CR here, is given by the swept volume plus clearance volume upon clearance volume. Usually the compression ratio is taken as 6, assumed as a 6 for 2-stroke engine, and for 4-stroke engine it is taken as 12. So this we need to assume, and it will not be a given data. So we can calculate the compression ratio. Actually compression ratio will be assuming it, and from the formula compression ratio is equal to stroke length plus top clearance upon top clearance. So we can calculate the L1, which is the top clearance value, and finally the length of the cylinder LC, because already we have calculated what is the stroke, top clearance is obtained from the compression ratio, and piston length is taken empirically as 1.25 the bore diameter, that is 1.25 D, and finally we can calculate the length of the cylinder. The next step is to calculate the thickness of cylinder wall T. The thickness of cylinder wall is given by the formula shown here, P max multiplied by the bore diameter upon 2 into allowable stress sigma allowable plus the reboring factor. The reboring factor C1 is usually given from the table, and it will be a given data, and that depends upon the cylinder bore which you have calculated earlier, and P max is the maximum gas pressure, usually that is also a given data in Newton per mm square, and the allowable tensile stress for the cylinder wall is taken in the range of 35 to 70 Newton per mm square for cast iron. So generally the cylinder walls are made up of made by cast iron, and this has to be an assumed data. Usually this data is not given in the problems, so we have to assume sigma allowable between the range of 35 to 70 Newton per mm square. Once the thickness of the cylinder wall is calculated, we also need to calculate what are the resultant stresses induced in the cylinder wall. And here you can see that the circumferential stress being the dominant stress, the resultant stress is given by sigma r is equal to sigma c minus Poisson's ratio multiplied by the summation of the radial stress and the longitudinal stress. So we need to calculate the circumferential stress, radial stress, and longitudinal stress, and they are given by these formulas. Already we have seen the formulas in the topic of pressure vessels, design of pressure vessel. So sigma c P max D upon 2T, sigma L P max D by 4T, sigma R is minus P max, that is acting in the opposite direction. So finally we will calculate the resultant stress induced in cylinder wall because all the other data are known. So Poisson's ratio will be given in the problem. Next step, third step will be to calculate the thickness of cylinder flange TF. And TF is generally given by an empirical relation, and it is between 1.2 to 1.4 times the thickness of the cylinder which you have calculated earlier. Next step is to calculate the thickness of cylinder head TH. So usually the cylinder head is assumed to be flat, and the same formula which you applied in the flat head of a design of pressure vessel topic, this formula has been applied there, where TH is the thickness of the flat cylinder head, D is the bore diameter, P max maximum gas pressure, and here K is the constant. We need to assume this constant, that is in the range of 0.3 to 0.4. It is not a given data, so again one more assumption has to be made. And sigma allowable, as we have stated for a cast iron, it is in the range of 35 to 70 Newton per mm square. So by this we will calculate the thickness of cylinder head. Next step is to calculate the diameter of the bolt or studs. So here you can see that the force which is generated because of the gas pressure, that is pi d square by 4 into P max, is equated with the force because of the stresses induced on the cylinder head, and it is given by area into number of volt into the stress. So usually the top head, the bolts undergoes the tensile stress because of expansion. So you can see that uh, here this bolt undergoes tensile stress because of the internal pressure, because of this internal pressure P max. And because of this, the tensile stress is induced in the bolt. So we'll calculate the value of DC, and once you obtain the value of DC, you can calculate the bore diameter dB, which is DC upon 0.84. So number of bolts usually taken in empirical relationship. So it is taken in the range of bore diameter upon 100 plus 4 to bore diameter upon 50 plus 4. So usually the bolt should be in multiples of 4. That is why this 4 is being added. And once you got the range, you will select the number of bolts. Those should be in multiple of 4. And finally, the nominal diameter of the bolt should be less than 16, should not be less than 16 mm. So 16 mm is the cutoff range for the nominal diameter of the bolt, and it has to be assumed more than that. Those who are designing, this should be considered as a major factor. So finally, before going to the last step, we need to calculate the diameter of pitch circle of bolt and the flange. So diameter of the stud pitch circle is given by d plus 3 times the diameter of the bolt. It is an empirical relationship, and here you can calculate. Already we have calculated the value of d, and the diameter of the bolt which you obtained from the previous case, and finally we will calculate the diameter of pitch circle dp. The next is to calculate the outside diameter of the flange do, and it is given by dp plus 2 times the bolt diameter plus an allowance of 12 mm. This 12 mm is constant. And finally we'll calculate the pitch of the bolt PBO, because this is a major factor which will determine the position of the bolts, and the pitch of the bolt is given by pi dp upon n. dp is already calculated, which is the diameter of the stud pitch circle, and usually we have to verify the calculated pitch of the bolt. For safety, they should be in the range of 19 root of dB to 28 root of dB. So if they are within the limit, then the pitch of the bolt is selected. Dear students, this brings to the end of first topic, design of cylinder and cylinder head. Problems related to design of cylinder and cylinder head will be discussed in my next video. I'll be releasing it soon. This is my first attempt to produce this type of video. If there are some feedbacks, please feel free to share at my mail ID. I have displayed my mail ID here, and you are also free to ask any queries related to the topic which I have discussed. Thank you for listening. Good day.